Hello. Welcome to Elasticsearch Master the ELK stack. So on this session, we are going to see how we can use Elasticsearch ELK stack for our application and how we can enhance our application for better searching. So let's begin. So the agenda for today live session is introduction to Elasticsearch, introduction to Kibana, introduction to logstash, and then we have a demo. So let's begin and see what is Elasticsearch. Elasticsearch is a search engine. When you use Google to search something, you have seen features like auto-completion. Did you mean this? Spelling correction, multilingual search capability, stemming, synonyms, highlighting, and more features like this. These all features are supported by Elasticsearch, and you can use these features in your own web application using the power of Elasticsearch. So let's see what is Elasticsearch. Elasticsearch is a document-oriented database designed to store, retrieve, and manage document-oriented or semi-structured data. When you use Elasticsearch, you store data in JSON document form. Then you query them for retrieval. Basically, Elasticsearch is a database, or simply you can say it's NoSQL database which supports big data and which is easily scalable, and it stores the data in the form of JSON document. So let's see the story of Elasticsearch. Elasticsearch is created by Shai Benon. Shai Benon created Elasticsearch on year 2010. The previous version of Elasticsearch was called Compass. Elasticsearch is an open source project which is made on the top of Lucene search engine. This is Shai Bannon, the founder of Elasticsearch. Elasticsearch is an open source server written in Java over Apache Lucene library, used to index any kind of heterogeneous data, enables real-time ability to search through index, and has a REST API web interface with JSON output. Elasticsearch is built on top of Lucene, which is also a free open source search engine library which is written in Java. The author of Lucene is Dog Cutting. An index of 10,000 documents can be queried within millisecond using Lucene. So let's see how Lucene stores the value. When you pass any document to Lucene, as you can see in this diagram, we are passing document 1, 2, 3 into Lucene. It creates an inverted index for that. All the terms, or you can say all the words of your documents, are divided into tokens or term along with the document and position. Every time you insert a new document into Lucene, this inverted index table is rearranged. And when you want to search for some keyword like blue sky, you will get the response as document reference 3, and it will also give you the relevance score depending on the term. Lucene indexing. Index is incremental updatable. Newly added documents go in tiny new indexes. Bulk of index is in large index segments. Segments merged in background. It supports lazy merge sort for optimal, scalable, and with the time complexity of n log n. It supports fast search. All the data which you pass into Lucene are stored in the form of segments, and segment contains the inverted index. So let's see what are the basic components of Elasticsearch. Elasticsearch have some new terminologies like index, document, cluster, shard, and replicas. When you create a Elastic server, you create a cluster of Elastic server, which is combination of multiple nodes. Each shard is one Lucene instance. The copy of shard is present in replicas. Index is a combination of multiple shards, and document is the entity which you want to insert and search. So let's see the Lucene architecture. At the top, we have application layer through which we can search and analyze. Then we have index. Below the index, we have storage. We can store our index on any storage device like hard disk or memory. Let's see the common terms in Elasticsearch. We have node on Elasticsearch. A node is a single instance of Elasticsearch running on a machine. Cluster, one or more instances of Elasticsearch connected to each other under a single name. Index is a logical namespace under which Elasticsearch stores data and may be built of using more than one Lucene index using shards and replicas. Shard is a distribution of data where documents actually lives. Replica is duplicate copy of the data living in a shard for high availability. Doc types. A type in Elasticsearch represents a class of similar documents. An index can contain more than one type. But for the new version of Elasticsearch, it is recommended to have only one type for one index. So let's see in this diagram what happens when we query some data on Elasticsearch. So your request first goes to the coordinating nodes, which is Elasticsearch instance. Then it routes the request to different shards in your instance. Inside a shard, we have multiple process going on. In background, you can see we have memory buffer, transaction log. From memory buffer to file system cache, we have a refresh time of 1 second. Every second, the memory buffer data is copied to file system cache. Then it's committed with translog flush into our hard disk. Commit of transaction log happens every 5 seconds with every write operation and when flushed. Flush every 30 minutes or get too big. Flush is like cleaning our transaction log every 30 minutes. So in this diagram, you can see what is really happening inside a shard. As you know, Elasticsearch, when we deploy on any system or in cloud platform, we are using Elasticsearch using Elastic Cluster, which is a combination of multiple nodes of Elasticsearch. If you go inside one node of a cluster, one node is made of shard. Shard is itself a lucene, which is also known as inverted index. All the data we add goes into our shard, that is lucene instance, and when we search of any particular document on Elasticsearch, the data is returned back from shards. So let's see how the data is stored in Elasticsearch. On our previous slide, you have seen what was happening inside a shard. On Elasticsearch level, when we insert a document, a translog is created to keep track of recent changes in case of failure. We have a refresh that make documents searchable, and flush operation store changes to disk. On Lucene level, we have flush, commit, and merge. Flush means writing translog to new segment. Commit, we are doing file sync with the operating system. On merge, we are optimizing our segments on Lucene. On disk level, we are writing into disk. Whenever we restart our node server, we have recover committed shard. The shard with matching sync IDs are considered identical. For that, we replay the translog to recover recent changes. So by now, you understand how Elasticsearch stores data and what are the steps which are happening inside Elasticsearch. Let's move forward. In this diagram, you can see on Elasticsearch, we have at the top the index, which is nothing but the namespace, and which can be a combination of primary shard and replica shards. As you know, each shard is a lucene index in itself, and each lucene index contains multiple segments. So the smallest building block on Elasticsearch, you can say, are the segments. The combination of segments create a leucine index. A leucine index is a shard, and the combination of shard creates a elastic index. So moving forward, you can see in this diagram server 1, server 2, and server 3. Suppose these are the microservices or any web application which are running on your cloud platform. Suppose we want to get the logs of server 1 into our Elasticsearch. We will use FileBeat. FileBeat helps us to ship our logs directly into Elasticsearch, or we can use FileBeat for shipping the logs into logstash. Logstash collects and transform the logs and put it into Elasticsearch. We can visualize our logs using Kibana interface. As you already understood that ELK is combination of Elasticsearch, logstash, and Kibana. Combinedly, it is called ELK stack. So let's see the centralized logging with ELK stack. Suppose we have multiple application server running on any cloud platform, and we want to get the logs into one centralized system where we can manage the logs and analyze it easily. So for that, most of the companies are using ELK. So this can be done using the log shippers, or we can say the FileBeat programs that help us to ship our logs into Elasticsearch. To make our logstash indexer safe from flooding, we are using broker in front of our logstash indexer. You can use any kind of broker like Redis, RabbitMQ, Kafka. So by this setup, you can see we have one client per host. We have Java installed on every system. And we have higher fault tolerance. In this diagram, you can see the different steps involved in using ELK. First, we have data collection. Data collection can be done using bits. Then, for buffering, we have Redis, Kafka, and RabbitMQ. For data aggregation and processing, we have logstash. For indexing and storage, we have Elasticsearch. And for analysis and visualization, we have Kibana. In this diagram, you can see a basic architecture of ELK stack, in which we have user group A, user group B, which have a data store and web APIs. In user group A server, we have to install bits. The bits will send the logs into Kafka, which is a messaging queue. From Kafka, the data will be transferred to logstacks, and from logstacks, the data will be transferred into Elasticsearch. So let's move into our demo part and see how we can use ELK in real time. So for that, you need to download and install Elasticsearch, Kibana, and logstash into your system. You can download Elasticsearch from elastic.co, which is the official website for Elasticsearch. On products, you can see Elasticsearch ELK stack, where you have Elasticsearch plus Kibana. Kibana is a user interface for Elasticsearch, which is a stunning visualization tool where you can analyze and visualize your data. So first you need to download Elasticsearch. You can download Elasticsearch from this page. Based on your server operating system, you can download particular file from this website. You can also run Elasticsearch on Docker As I have already downloaded these files in my system, as you can see, I have already downloaded Elasticsearch here. Inside my Elasticsearch folder, we have a bin folder from where we will run our Elasticsearch. I have also downloaded Kibana and pasted it inside the Elasticsearch folder, and also downloaded logstash and also placed it inside my Elasticsearch folder. I am using Elasticsearch 7.3.2 version. So let's see how we can run our Elasticsearch instance locally on our system. First, we need to go and open your terminal. Go to the address where you installed your Elasticsearch. I have installed my Elasticsearch on my documents. You need to go inside Elasticsearch folder and inside bin folder you need to run Elasticsearch file. So when you run this file, it will start Elasticsearch locally on your system. Before using Elasticsearch, you should have installed Java on your system, because Lucene and Elasticsearch are written in Java. So for running this software, you have to pre-install Java on your system. As you can see, the Elasticsearch server is now running in my local system. To test that our Elasticsearch is working correctly, we need to go to our browser and type localhost 9200. When we hit this API, this URL, you will see a message which gives you the Elasticsearch cluster information. Name of the cluster, name of cluster, the cluster UID, the version which we are using, the version of Lucene which we have. As your Elasticsearch is running successfully on your local system, now you can run Kibana on your system. As I told you, I have already downloaded Kibana into my system and unzipped it and paste it inside my Elasticsearch folder, as you can see it here. This also have a bin folder and a Kibana file. So on one tab we are running Elasticsearch, on another tab we need to run our Kibana. For that, we need to go inside our Kibana folder into bin folder. Then we have to start Kibana using this command. I am on Mac. That's why I'm running this executable sh file. On Windows, you will get a bash file that you can run from your PowerShell terminal. As you can see, Kibana is running. And to test that Kibana have restarted successfully, we need to go to localhost port number 5601. When Kibana started successfully, you can see our Kibana. As Kibana server is not ready yet, it will take some time to start Kibana locally on your system. You need to wait for some time. Okay, I think now my Kibana is started. Again, I will refresh the page, and now you can see the Kibana is loading. Kibana is a user interface for Elasticsearch. It provides us a dashboard where we can do our analysis and visualization of our Elasticsearch data. Alright, now we have our Kibana running on port number 5601. So this is how the Kibana dashboard looks like. It have multiple menus here on your left. You can see. We'll go to DevTools. DevTools gives us facility to write queries for Elasticsearch. We can write and run our queries of Elasticsearch on DevTools, and we can see the result on right side. So let's see how many cluster indexes do we have inside our locally running Elasticsearch cluster. When I click this one, you can see I have about 8 indexes which are running on my local Elasticsearch cluster. When you write pretty or verbose, for verbose we are using V, and when you click on the play button, it will show you the data in beautified way. So it will be easy to read on this dashboard. So you can see the health of index here. Health is defined using colors. We have yellow, green, red color for index health representation. Then we have status, that this index is open. Open index means we can do query, we can do search queries, indexing queries on these indexes. Every index have its unique UID, and the number of documents you can see here we have on this particular cars index. How many documents have been deleted, what is the store size, This all information you can see using cluster API. Moving forward, we have many APIs which are given by the Elasticsearch. Like if you want to do some insert operation and you have bulk of data to insert, so for that we have bulk insert API. So we can insert these documents using the post HTTP method into our cars index. We can also do aggregation on our index using Elasticsearch aggregation API. We can create the snapshot, or you can say the backup of our Elasticsearch cluster or any particular index using the snapshot API provided by Elasticsearch. In that, we need to pass the type file. Inside setting, we need to give the location of folder or directory where we want to keep our backup, and bytes per second for making a snapshot. If you click on this icon, you will see we have auto intent, which will adjust your query here. And if you want to run this query on your postman or using the curl operation, you just need to copy that query from Kibana, and on your postman you can go and import, paste the curl query inside the import box, click the import button. Now you can run your query from Elasticsearch. Suppose you want to run this query, then you need to just copy this as a curl, go to your postman, go to import button, go to the paste raw text and paste your query here. When you click on import button, now you can see your query here, and when you click on the send button, you will get the response here. As you can see, the cluster name, cluster status, timeout, number of nodes we have, number of data nodes, number of shards, active shards, All this information can be found using the cluster API. Okay, now you are familiar with Elasticsearch and Kibana. You know how to run it locally on your system. Let me show you how you can use logstash. So for that, you need to first download logstash locally on your system. Logstash is used for filtering and modifying the logs and sending it to the Elasticsearch. For example, I am using Node.js server to create logs. These logs we want to transfer using logstash, and we can visualize it on Cabana Dashboard. So on left side you can see I have a Node.js application. It's a simple Node.js application which uses Winston for creating logs. On Express is used for creating Node.js HTTP server. Let me run this server by using the command npm start. So now the server is running on port number 3000. So let's go and check on port number 3000. Okay, we got the response. I have a file as logger.js which uses Winston for log management. So Winston is a Node.js log management tool which is used for transporting our logs into multiple locations. So for that, we need to define our transporters. Here I have defined two transporters for our Node.js application. One you can see I have given a file name combined.log, which you can see here. All the logs of our Node.js Express server are appending in this log file. Other than that log file, I'm also sending logs into MongoDB. For that, I have given the address of MongoDB and the document and the database name. Logs can be of different level. Logs can be an error, logs level can be an info. So based on logs level, we have created different log collection on MongoDB. So let's open our MongoDB and see. Inside text we have error log and info log. When I open error logs, you can see we have multiple error logs. In that we are storing the timestamp of the log, the level of log, the error message, and the meta message. On info logs, we are also storing the timestamp level. Here we have info as a level, message, and the meta. Okay. So for sending this logs into Elasticsearch, we will be using logstash. For logstash, we need to create a config file for logstash. As you can see, we have created a config file for logstash. We need to give the cluster name. Our cluster name is Elasticsearch. So this is the configuration file for logstash. It takes input, output, and filter. The input it will take from combine.log file, which contains all the logs of Node Express server. It will read the logs from the beginning. On output, it will send that data into Elasticsearch, which is running on port number 9200. So for running this file, we need to go into our Elasticsearch. I have pasted the logstash inside my Elasticsearch folder. Like other files, it also have a logstash file inside the bin folder. So you need to go to your terminal and go to your logstash bin folder. And you need to run this command. So we are giving this config file which I have created, and on input I have given the combine.log file address which holds all the logs of Node.js application which we are running locally on our system. So these logs will be forwarded to Elasticsearch. So whenever we hit any API on our Elasticsearch server, it creates a log and when we give incorrect address, it will create a error log. All these logs will go first to combine.log file, then the MongoDB which we have given using Winston. On MongoDB also you can see we have 27 here. When we refresh it, now the count of logs is increased. So now you understood how we can use logstash for sending our logs into our Elasticsearch cluster. If you want to visualize your logs, you can go to source, select your index, and all logs you can see here. Thank you everyone for joining this session. If you have any kind of doubt or any suggestion, you can connect me on LinkedIn. Every week we are coming with new topics on our channel. If you have not subscribed our channel, you can subscribe and click the bell icon. So till then, keep learning, keep growing. Have a nice day.